Hi, hello, this is Nicholas Sostek.
And I'm Michael Paiva.
And this is week 2 for our Paiva and Sostek aftermarket ammeters. All right. So what we accomplished this week is we redesigned our whole circuit due to complications we found throughout the way. This is our new power supply circuit. So what we did is we had to make a latching system so the SD card wouldn't fry out as we are turning it off and on. And we added these other chips, and you can see the new GPIO outputs. You can see the 3.3 coming from the Raspberry. You can see the 10 volts going in and the 5 volts coming back out.
And this is the Raspberry Pi Pico. You can see here, we take the 5 volts from the power supply that we just talked about. We run it through a MOSFET and power the Raspberry Pi Pico. But we can also power it via USB, which will disable the 5 volts in. That would be for debugging and anything like that. And then the 3.3 volts out, you can see here is to power all the 3.3 volt logic level stuff.
Here's the non-volatile I2C memory circuit that we have built, and you can see the 3.3 coming from the Raspberry Pi, and you can see the GPIO outputs going into the Raspberry Pi that we will use to store our memory for our readings and everything.
So this is the 24-bit ADC circuit. We are using 2 buffers to buffer the input from the shunt resistor, and this would be attached to the wherever it would be attached in the car. We're planning to attach to the ground rail of the battery. This is using SPI communication, and we have to have this anti-aliasing filter here. But during testing, this did not work. I can't get this thing to work at all. So we are thinking about reducing this to a 16-bit ADC, which would be I2C, and is much easier to work with.
So this is our SD card schematic. You can see the 3.3 coming from the Raspberry Pi. You can see all the GPIO outputs into the Raspberry Pi, and it is using crap, I'm blanking right now.
SPI communication.
Yeah, SPI communications that goes to the Raspberry Pi and everything.
So this is our LED bar graph. We're using an LED driver, which simplifies things a lot. It uses I2C, and you just write the registers to control which LEDs are on and which LEDs are off, and it can control the brightness. And it uses this one resistor because it's a constant current output. So it uses this one resistor to set the current for each of the LEDs. And this LED driver is capable of running 57 milliamps per channel. And these LEDs, the LEDs we're using only use 20 milliamps. So this is when we were testing the SPI, the 24-bit SPI ADC, which is right here. We can only find the individual IC. They don't have a breakout board or anything like that. So I hand soldered this on there and then tried testing. You can see this is the FRAM for non-volatile memory. These are just level shifters. You can see the start of the bar graph here. This chip is 2 op amps. and they're configured in to make the 2 buffers. And then you can see the start of the SD card connection right here.
And then this is the power supply circuit that I was able to build so far. I'm just waiting for some more parts. I also had to hand solder the chip onto there because we couldn't find anything. I started as much as I could with what we have. I'm still waiting for the relay to come in. I'm waiting for another inductor. Those 2 chips I need to replace. Those are just placeholders, so I can until I get the real one, so I can put the actual ones that we need in there. And that's pretty much it. I wasn't able to test it because I don't have some of the things that I need, but hopefully either today or tomorrow they're coming, so I could build the rest of the circuit and start testing it out. This is just some more of our costs, some of the new chips that we had to buy since we had to redesign stuff. We bought extra ones just in case, because hand soldering, sometimes you accidentally can fry them. And so there's that.
So this, we had to redesign our power supply and some of the other circuits that we are using. We did have to reorder some different parts that we needed. And I did build the ADC circuit. And Nick did build part of the power supply. And I tested the ADC, but I couldn't get it to work.
Difficulties we encountered, we had a difficult time finding a chip that was in stock. Luckily, what we needed was in stock. We had to redesign most of our system due to some flaws that we found in the previous week, but we were able to resolve all that. We're pretty much just waiting for certain components to come in the mail so we can just move forward in the building and the testing. We had difficult setting up debugging the environment for the Raspberry Pi Pico, as Michael has said, but hopefully with the 16-bit that will all be resolved sometime this week.
So next week, we hope to have all the parts and test all the individual systems for this project. The power supply hopefully should be built this week or next week, and we'll continue building and testing all the individual subsystems.
This is the updated Gantt chart. We just updated all the dates and how long it will take us. We pretty much just had to make everything, instead of 1 week, 2 weeks because of what happened this week, but it's only a temporary setback. We should be up and running after at the end of this week for everything, and just be able to move forward with the rest of what our Gantt chart shows right there.
And this is just the individual breakdown for everything we just discussed in the Gantt chart.
Yeah, we just updated this as well for our work structure update. And that is our presentation for week 2.
Thank you.
Thank you.